Okay, we'll go ahead and get started here. This is Julianne, and I want to welcome everyone to part two of our webinar series on industrial remote connectivity. Today, we will be discussing how a cloud-based always-on communications network can help utilities increase their productivity and service levels. So again, the Q&A box is there for you to ask questions, and we'll get to those at the end. So now I'm going to introduce Vishal again. He's our product manager for IIoT and remote connectivity, and I'll hand it over to him.
Thank you, Julianne. Again, welcome everyone. And again, I hope that all of you and your families and friends are staying safe and healthy given the current global health crisis. So today's session, like Julianne said, is part two of a three-part series on industrial remote connectivity with the focus on how to improve productivity. And today what we're going to be looking at is sort of an always-on network for utilities. So utilities, be it water, wastewater, power, is really critical infrastructure, and they face several challenges when it comes to providing efficient delivery of their service. And one of the main challenges is dealing with connectivity to geographically dispersed sites. So in this session, we will look at how an always-on network is vital to maintaining that secure remote connectivity to remote sites, which would thereby increase their efficiency and productivity. So before we get going, just a quick introduction on who is ProSoft. So ProSoft has been in business for over 30 years. We're a global organization with offices around the globe, located strategically, of course. So we partner with major industrial automation vendors and really become their communications arm. Whether it's Rockwell, whether it's Schneider, we really become the communication experts. And so over this period, our strengths are in two main areas. First, we really are the best choice when it comes to connecting disparate protocols on the factory floor. And today we support over 40 different protocols and sort of over 120 different combinations of those 40 protocols. And we support everything from legacy protocols through to many of the new ones like OPC UA and IEC 61850 and DNP3. So you sort of have these older proprietary protocols, which we also support, but also many of the new open standard ones. And the second strength of ProSoft is really to transport your data, whether it's through wired or wireless means. We transport that data safely and securely for you. So if you think about our strengths, the two strengths that I just mentioned, and if you look at the triangle that I have up there, ProSoft is really your first step when it comes to any connectivity or IIoT type journey. All right, so let's look at utilities. So utilities refers to a category of businesses that provide service, and they can be from basic services, like water and wastewater, to more advanced services like medical. They're part of the public landscape, and really today, we as a society cannot function properly without many of these services. We will be focusing on the basic services, which is water, wastewater, electricity, and gas. And if you look at what's common among these utilities that I've just mentioned, they are very heavily regulated by governments around the world. They are considered critical infrastructure, so they do enjoy special status, but they've also got more advanced security requirements that they have to adhere to as well. The other thing that's common with all of these utilities, it is a continuous service. I mean, we all want water to come out when we turn on the tap. We want the lights to go on when we flick the switch, or we want the gas burner or the stove or whatever it is to turn on when we push the button. So these basic utilities is a continuous service, and something that's important because as we talk about efficiency, it's important to keep that in mind. Utilities are managed by semi-government agencies, so they kind of run as an organization, but they're really answerable to the government primarily because they're heavily regulated. Or in North America, in the United States in particular, many of these utilities are run by municipalities. And these utilities play a very significant role in promoting the economic development activity locally. You can imagine without these services, what would happen to some of the more economic development activities. And in many of these projects, they would not even get off the ground without any of these services. The other thing that's common for utilities is that they are very geographically dispersed. So most utility assets are not concentrated in a small area. They are spread over a very, very wide area. So if you look at, for example, the image on the left-hand side, that's an image of the groundwater resources here in the Northeast, many of the states in the Northeast. And if you look at the image on the left, so that obviously, going back to the image on the left, if you look at that covers several states, a really large geographical area. So imagine the challenges of having to monitor all of those locations and bringing back the data, and at the same time ensuring then, because the service in this case would be the supply of fresh water service, ensuring that that service is continuous and it is reliable and it is secure as well. The map on the right-hand side is actually of a city in New Zealand, and it's a gas distribution system. And again, as you can see, the infrastructure is over a large geographical area. So like I said, for any utility, in fact, the assets are always geographically dispersed and they spread over a large area, but the requirement is the same. So it still needs to operate reliably and so forth. Okay. Oops. Let me go on to the next slide. So what are the key requirements for utilities? And let it be any type of utility. So this is actually an example here. I've shown the coverage area for the city of Portsmouth. Again, being a municipal, they provide water, wastewater services. But key requirements for any type of utility, I've chosen this example, but it could be anybody, is reliability. And if you look at reliability, then that's their core, because they're there to provide a service. And if it's not reliable, then you're going to have the city not being able to really function very well, and perhaps even cease to exist. So fairly disastrous consequences. Scalability. We all know the growth in human population, the increase in urbanization, and all of those things. So the ability for the utility service provider to scale is a very key requirement. And it is something that is absolutely important for them to ensure that they have the plans and the processes in place for them to scale accordingly, driven by demand. Of course, this is not one of those cases where build and they will come, although it does happen in some countries. But this is really having the plan in place to ensure that the solution, the service you're providing, is scalable. The other one is coverage. So scalable and coverage, they sort of tend to go hand in hand. You want that scalability to expand, and coverage is really to making sure that that geographical area for which you're responsible for is fully covered, that all citizens, that all people in that region can get access to the services, those basic utility services. Now, the other key requirement is connectivity, and we're going to talk a little bit more about connectivity, especially the evolution, in the next slide. But connectivity, again, is very important. So a very large area, they've got assets all around, that geographically dispersed area, being able to connect to every one of those assets in a timely fashion and bringing back the data is something that is very, very important. The next requirement is security. So this was always not a key requirement, but since the unfortunate incidents of 9/11, all utilities are now critical infrastructure. So they have a very, very high security standard that they have to adhere to ensure that, again, that service is reliable, that it has got coverage for the entire area. And you can achieve that by ensuring that security. And it's not a one-step process. The security covers everything, from the equipment being used through the processes, through to the actual, the science behind it, everything. So there's a security component to every part of that. And the last part, the last key requirement is data acquisition. Because without data, we all know today that data is power. So without that ability to go and get data from those remote assets, you're not going to be able to provide the service. So data acquisition, reliable data acquisition is a very key requirement. Now, we looked at the requirements, and I mentioned that I'm going to talk about the connectivity a little bit more. What I really wanted to talk about is the connectivity evolution. And connectivity is as old as mankind, really right from Middle Earth all the way to down. And it has evolved, from us lighting fires to convey messages in Middle Earth. It has certainly evolved significantly, especially over the last sort of 50 to 70 years with the increased industrialization, automation, and urbanization, and the move towards better living standards. There has been a fairly drastic change in connectivity. And that sort of is a holistic view. We're going to narrow that down to how it affects us in the automation space, and especially here in utilities. So if you look at this evolution, and clearly I'm not going to go back all the way to Middle Earth to see what's evolved, but if you look at what's happened over the last sort of 50 to 70 years, the initial connectivity, the initial systems were all fixed line. It was more point-to-point type connectivity, where it was good in its day, and clearly that was the technology that was available. It was good in its day, but it is slow. These generally leased lines typically only tend to operate at sort of 1200 bits per second, where today we are talking about gigabits in some of the other communication standards. But like I said, good in its day, but very slow. It was fixed. It was unreliable as the service grew. It was not very easily scalable. It was pretty expensive, and it has gotten even more expensive to maintain. And in many cases, the service is just no longer available, just given all of those things. The service providers themselves do not want to provide fixed line communication that has better technologies, that are better services out there. So simply continuing to use this really does not improve the efficiency of the system. And sort of the next part to lease line was really PSTN, or publicly switched telephone networks. Same thing, great for the day, but again, expensive, unreliable. And today, if you think about it, who's got a landline phone? Very, very rare. There was then a very quantum leap to radio, which I call it quantum because it went from hardwired to wireless, so very common, still widely used today. In a lot of the areas, and again, while it was good in its day, today with radio communications, they offer very, very minimal to no security. It is still low speed and low bandwidth. We're only talking about 19K2, maybe 115K, but still relatively slow speeds. And the reliability of this radio-based wireless communications has decreased with the increased use of urbanization, and especially with more and more people especially if you look at sort of unlicensed frequencies, as more and more devices get on that, everything from your garage opener through to toys, this has become very unreliable for critical infrastructure like a water utility. Sort of the other thing with radio, the communications do affect it, obviously, with urbanization, and if you don't have that line of sight, you've got some issues. What's happening now in the world, there's this explosive growth, especially in the last 15 years with cellular wireless. So this is also wireless technology, but it is cellular. It's one of the few areas where philosophically, things, it's like build and they will come. And if you look at today, which is true in the consumer world, especially with telecom, because they're continuing to put out, customers are still using 4G, but we know that 5G rollout has already begun, and they've already started talking about 6G. And the innovation on the hardware side is also happening to keep pace with that. But there's an advantage to industry. That's what's happening in the consumer world, which is fantastic. We all love our iPhones and we all wait for it and so forth. But I think there's sort of this underlying advantage to industry, because now what you've got is sort of this readily available infrastructure that's continuing to grow at a fairly rapid rate. But not only is it growing, but it's becoming very, very reliable. In fact, to the point that the second most important, or the second most abundant thing available on Earth, other than the air we breathe, is really cellular coverage, which is pretty amazing considering that all of this has only happened in the last sort of 15 to 20 years at the most. So this evolution of connectivity technologies that's happened really, what it's helped is it's helped utilities in a significant way, because now they can move from some of these more antiquated and more unreliable communications to something that's secure, something that's high speed, high bandwidth, more readily available. And fundamentally what it allows them to do is to really focus on their service while allowing the communication experts to handle getting that data for them, or enabling the communication between all of their sites. Previously, many of these networks had to be maintained by themselves. They had to keep them in play. So the cost was quite high, whereas now you're relying on this readily available infrastructure, which significantly reduces your cost. So how can an always-on communication network help utilities? If you look at the benefits, and again, I'm going to go back to the example that I used previously. If you look at some of the examples, when you've got an always-on network, you can get your alarms very quickly. Now, it is not just the communication evolution. There's another important part to this, and that is protocols, so industrial protocols. You'd remember that I mentioned that's one of the key strengths of ProSoft as well. But protocols, which fundamentally is a language that's used to communicate between two controllers' machines, they've evolved from being proprietary to being more open, more robust, more secure, with additional diagnostic elements built into that protocol to ensure that the system is operating efficiently and reliably. And the combination of that protocols and that evolution in connectivity, what we have now, a big advantage for utilities is the ability to get alarms faster. So from an efficiency standpoint, if you're able to get your alarms quickly, you're able to react, you're able to minimize the impact of a breakdown or lack of communications or service breakdown, address that issue quickly and resolve it, ensuring that service standard that really is the fundamental activity of a utility organization. The other thing that there's connectivity, this improved always-on connectivity can do is to help reduce the mean time between repair, or MTTR. So again, if you look at things, for example, with an always-on network, the ability to access that at any time means you can do things like first instance analysis, the ability to get a better understanding. So like when you have to go to site to solve the problem, you can reduce the amount of downtime. And that's where that comes in. Always on networks, which are mostly high speed and high bandwidth, allows you to bring back more data, which means you can do better predictive maintenance modeling. You can ensure better asset life. You can do better scheduling, better maintenance. So there's a lot of advantages. Like I said, data is power. So the ability to bring back that data and do analytics is extremely useful to increasing the efficiency of a utility system. Security. Like I said, today utility is a critical infrastructure, so security has to be continuous. It's not something that you would do at the startup and then turn off, or it's not something that you would run once a day and say, okay, my system is secure for that time that I ran, so I should be fine till tomorrow. It doesn't quite work that way. So security is continuous, and the only way you can ensure that the load that security processes and protocols place is to ensure you have this always on connection to the remote site. Sorry. Another huge advantage is remote access. And again, if you think about previously with some of the older systems, the ability to connect to a remote asset is not there because there's no direct connection. It'll be an indirect connection, if that, or you will need to get to a point where you can connect to the mainframe and then access some of these remote sites. But with an always on, and especially with cellular-based infrastructure, the ability to remotely, securely and quickly connect to the sites is a significant advantage, because that then helps you things like resolving issues, further reducing your mean time to repair, and so forth. And then the final benefit, I think, is peer-to-peer communications. So this really is where the reliance on one point or one, the master location in the system is no longer required. Think about something as simple as a tank and a pump station, that if the tank is getting full and it needs to ask the pumps to stop, in most traditional systems, utility systems, the information goes to the master. But what happens if the master fails? Does the tank overflow because the pump station has not received a message? Which could happen. So you would then have to send people out there to manually turn it off, which again is a solution, but it does not help with reducing mean time. It does not help with resolving an issue quickly. Whereas with peer-to-peer comms, even if the master is not functional for whatever reason, then let's say the tank side could send a message to the pump station to say, turn off, I'm full, something as simple as that. And if you look at these benefits, when you combine these benefits together, is what leads to increased customer satisfaction as a utility organization. Because remember, your primary focus is to provide the service, and the customers are not satisfied, that service does not equate to anything. So by focusing on these benefits and ensuring this always on connectivity, you can ultimately affect customer satisfaction, which is critical. So what should you look for? Clearly this can be a topic unto itself, and it's something that's very detailed, but given the limited time, I think one of the things you need to look at is make sure that the service is a managed service. And the reason I say that is, remember, as a utility organization, your primary focus is to focus on the delivery of your service, whether it's water, whether it's wastewater. Like I said, turn on the tap and you get flowing water, flush your toilets and it works correctly. Whether it is turning on the switch and getting power, it is delivering the service. So by having a managed service, and always on managed service, you can focus on the most critical KPI, which is delivering the service, and allow the experts to manage a communications network to give you everything that you need to meet your KPIs. The other thing that you want to look for in the solution is to make sure that it's OT friendly. So a very simple, easy to use, because again, remember, the focus is on providing the service, the utility. You don't want to be spending time getting trained and dealing with communication issues. So an OT friendly solution that's easy to use, that's scalable, that's reliable, and probably the most important thing is to make sure that it is platform and carrier agnostic. So think about like a larger city that might have, water utility at a large city or a gas distribution system at a large city. And if you're using cellular, um, no one part of the town would have excellent coverage from all of the service providers. And let's say if you take the example of the United States, you've got two main ones with AT&T and Verizon. It's entirely possible that one half of the city has got strong AT&T coverage, while the other half has got strong Verizon coverage. So as a utility service provider, what you're looking for is a solution where if you've got those geographically dispersed sites around your city, they can go on any network and you can still have a common top end. Because if you don't, then you've got two particular solutions they've got to bring in, you've got to amalgamate all of that, which does not help with efficiency. So what you're really looking for is a managed service that is completely platform and carrier agnostic. And then finally, you want the solution to be IT secure as well. And that's a given, given that utilities are critical infrastructure. As always, I've got one cheat slide. So ProSoft's PDN, or Persistent Data Network, is this always-on solution designed specifically for utilities. It really is super, super simple. I mean, it takes minutes to create the network and get the devices on. And it's really designed where all of the remote assets can talk to each other. You've got remote access. All of the secure multi-layered security approach with things like vLotto and two-factor authentication and one-time use on credentials. So a lot of the features that I spoke about clearly is there and a lot more. But ProSoft Connect is one of our fastest growing business units. We've got a number of customers in different utilities, which is interesting. So we've got customers in transportation, we've got customers in water, wastewater, oil and gas. They're all using PDN to enable that remote communications. So in summary, key requirements for utility service provider: reliability, scalability, coverage, security, and connectivity and data acquisition. We learned that connectivity has evolved, especially over the last sort of 15 to 20 years, where really today cellular is pretty much available all over the world. It's growing at a phenomenal rate, very, very reliable and secure as well. Additionally, the service provider would give you additional security as well. And then always on cloud-based communication network sort of offers very significant advantages to utilities that can help increase your efficiency and customer satisfaction. So as we said at the start, remember that this is a three-part series. So we did session 1 last week where we focused on how remote connectivity can help reduce your downtime. You sat through today's session, so thank you. We've got one more coming up, so same time, same day next week. And at next week's session, we're going to be looking at how a machine builders, engineers use a remote connectivity. How did they use that to help improve their own productivity? Very good. So with that, I will open up for questions if there's any.
Okay, we have one question here. It says, we use a radio network. How is this different from a cloud-based infrastructure network?
That's a great question. So a radio-based network, typically is more localized. Clearly, it's for your area. It is still wireless, but you're using RF communications. You've got to have your own infrastructure, whether it's towers, whether it's base stations, and then to make sure that there's line of sight between all of the sites. With cellular infrastructure, you're using something that's publicly available. So using the service provider's network. The advantage that ProSoft offers is we're taking advantage of that publicly available infrastructure, but providing a point-to-point encrypted network to connect all of your remote sites for secure communications. So we create pipes, tunnels, the word, to ensure that the data gets encrypted, where we only know how much data is in there, not what's in there. But we're simply using the network of, let's say, whether it's Verizon or AT&T, to really carry that data. The data itself does not traverse the network, does not stay in the network, which is unlike a solution from the service provider itself, because they're basically using the data is going through their network, whereas we create these secure end-to-end tunnels which are fully encrypted.
Okay. Another good question here is, if it's using cloud, does not mean my data is insecure.
Nope. That certainly, if you look today at where cloud computing is, if you look at the power of cloud computing and the resources that come in, it really is at the forefront. The data, like I said, even if you take, for example, PDN, it said we've got a multi-layered defense in-depth approach to security, where we've got everything from single-use channel credentials. So every time you connect, you're using a different set of credentials, which will never be used again. We've got two-factor authentication. You've got AES encryption. So, and then after that, you've got things like single sign-on. You've got, which is Active Directory support, or you've got vLOTO, which is virtual lockout tagout. So you kind of got all of these security features to ensure that this service is very secure. And the other key thing to keep in mind is, remember that with the cloud-based network, the PDN solution, your data is not stored, interpreted, or translated in the cloud. We simply create a tunnel, a pipe, from the initiation point, which is typically the master, through to the outstation, to send and receive that encrypted data. But that data is not stored or translated or done anything while it is getting from point A to point B.
Good. That's good to clear up. That's an important question. All right. If there's no other questions, we can end it. And thank you very much, Vishal. Thanks everybody for joining. And I hope you join us for the last one.
Thank you. And sorry we went a few minutes over.
All right. Everybody have a good day.